Okay, here is your answer key. Geez, I hope my volume works because it didn't for my poor Algebra 2 kids. These are all of the functions that we're going to try to match to the graphs on the next slides. So let's just get right to the graphs. Number 1 appears to be a parabola that's moved to the left 2 units. So that's going to be choice D. Ooh, hey now. Number 2 appears to be an absolute value function that moved to the right 2 units. That's F. 3 looks like it's probably an e to the x, maybe. Or it could be oh yeah, because e to the x goes through 0, 1. So that's e to the x that's down 1. That's choice I. Number 4 looks like an opposite sign function because it goes down. So that's H. Number 5 is a parabola that got moved up 1 unit. That's B. Number 6 is a cosine function that got moved up 1 unit. So that is J. 7 is an absolute value that got moved left 2. So that is G. A parabola that moved right 2 is C. Parabola that moved down 1 is A. And a straight line is E. Alrighty, those are those. Hopefully you're pretty good at recognizing transformations when there's no stretches or shrinks involved. Alright, next one. Now, for the domains of all of these, I'm simply looking for a fraction or a radical. Since 11, 12, 13, and 14 do not have fractions or radicals, I know the domain is all real numbers. For 15, absolute value is the same thing. It's still all real numbers. 16 through 18, we're going to look at the graphs and make sure we all know how to do it from a graph. So when I look at negative square root of 4 minus x squared. This is what I'm looking at. So I can tell from the graph the domain goes from negative 2 to 2. If I wanted to do that algebraically, I know the number under the radical cannot be negative. So I would say 4 minus x squared must be greater than or equal to 0. The absolute value of 4 minus x squared must be greater than or equal to 0. So I know that either 4 minus x squared is greater than or equal to 0, or negative 4 minus, or 4 minus x squared is less than or equal to negative 0. Which is also 0. So when I solve this equation, I get 4 is greater than or equal to x squared. So x is less than or equal to plus or minus 2. That doesn't really make sense. And here I get 4 is less than or equal to x squared. So x is greater than or equal to plus or minus 2, and those don't, it just doesn't make sense to me. So I have to go back to my calculator and say, oh, it's because it's between negative 2 and 2. So the domain goes from negative 2 to 2. 17, when we look at the graph, x over x squared minus 2x. It's harder to see a domain with a fraction because sometimes we have things called a whole. And you can kind of see right here that the graph splits a little bit when x is 0. Because remember, whenever you want to know the domain of a fraction, you must set the denominator equal to 0. So x squared minus 2x equals 0. When x equals 0, the function is undefined, and therefore that is not a member of the domain. So when I solve this equation, I can see that this fraction is undefined where x is 0 and where x is 2. The problem with 0 is that that's what's called a hole. Whenever you have the same factor in the numerator and the denominator, there's a hole at that point. But it's still not defined. It's still not a member of the domain. So the domain for 17 would be negative infinity to 0, union 0 to 2, union 2 to infinity. And then for 18, it's the same as this one, number 16. It's going to be a little bit funky, so we're going to look at it on the graph. 1 over the square root of 9 minus x squared. I have to get rid of all the rest of this stuff. It's also going to have a funky domain from negative 3 to 3. This time, however, different from here, when x equals negative 3, watch what happens. 3 squared is 9, 9 minus 9 is 0, square root of 0 is 0, and then you have 1 over 0. So this time I have to say from negative 3 to 3, but it can't equal those because the fraction would be undefined. Here in 16, the square root of 0 is 0, so it's defined. So these two, negative 2 and 2, are members of this domain, but they are not members of 18 because that would make the denominator equal to 0, and therefore it would be undefined. So the domain for 16 is negative 2 to 2, inclusive. The domain for 18 is negative 3 to 3, exclusive. The domain for 17 I wrote out, and the domain for all the rest of these is all real numbers, or negative infinity to infinity. Let's talk about the ranges. Ranges are a little bit more difficult. I know, because I've looked at a lot of graphs in my life, that an x cubed function looks like this and goes on forever, so the range is all real numbers. I also know that and if you didn't know that, you could look at it on the calculator. For this one, I know that it's a straight line. The slope is 35, the y-intercept is negative 602. The range is going to be all real numbers because it's a line that goes on forever. This is a parabola. A parabola does not have a range of all real numbers. So we are going to look at, where did that just go? What the range is. So the function is x squared plus 2x plus 1. So x squared plus 2x plus 1. Great.